This question is taken from the ENGAA 2020 section 1 paper, and it is question 7. The question reads, two fixed horizontal metal rails are side by side 12 centimeters apart. They are connected to a DC power supply by an initially open switch. A movable rod of length 20 centimeters is placed on the rails as shown. The diagram shows the setup seen from above. Rod and rails are at 90 degrees to each other. The setup is placed in a uniform magnetic field of 0.5 Tesla directed into the page, where the rod has weight 0.4 newtons. The switch is now closed such that a 2.4 amp current flows in the circuit and the rod moves. So what is the magnitude of the rod's initial acceleration and what is its direction? So given the context of the question, with the magnetic field, a current and some lengths given, the automatic response should be F equals B I L. So this is the force on the rod. So using Newton's second law, we know this should be equal to the mass times the acceleration. So that's how we can get the acceleration from this force. In order to get this, we know B, we know I. We'll think about L later. And we do know M. So the mass is simply related to the weight divided by G. So mass is weight divided by G, so 0.04 kilograms. So that's why they provided that bit of information in order to get the mass. So we know B, we know I, so what else should we use? Well, the actual length of the rod in the circuit as part of this circuit is 12 centimeters, so not the full 20 centimeters. So whenever doing forces, magnetic forces, the IL part, that current length, is related to what part is actually in the circuit. So if they were 20 centimeters apart, then I times 20 would be used. But here it's only 12 centimeters within those two points. So we have acceleration is 0.5 times 2.4 times 0.12, 12 centimeters, divided by 0.04. So doing some simple cancellations, should get 0.04 and 0.12. This divides you get 3. And then the answer for the acceleration is 3.6 meters per second squared. So we've got the magnitude of the acceleration. So now what is the direction? So immediately we should think of Fleming's left-hand rule. So if we've closed the switch and we've got a current flowing through, the current must be going down. So we're looking at this from above, so the current must be going from top to bottom. And then we know the magnetic field is going perpendicularly into the page. So the magnetic field is going in, so this is your index finger, and your current, which is your middle finger, is going down. So using your left-hand rule, the force must be going to the right, so from left to right. So the answer is F. So the force is directed to the right, and the acceleration is 3.6 meters per second squared.